All right, let's talk about a threat that could literally end civilization as we know it. And no, I'm not talking about some sci-fi alien invasion from another galaxy. This is a danger that's lurking right here, in our own solar system.
So, I want you to think about this for a second. Is there a hidden danger lurking up there? I mean, when you look up at the night sky, you see all this beauty, right? But what if? What if there's a danger hiding in plain sight? One that's been orbiting right alongside us for billions and billions of years?
Because that's exactly what we're talking about here. These aren't just pretty rocks floating in space. If the right one on the wrong trajectory heads our way, well, it has the power to just erase everything we've ever built. I mean, those are the stakes, and believe me, they are very, very real.
Okay, so to really get a handle on this danger, we've got to go back, way back to the beginning. Let's dig into the story of what was left behind. So, the main source for most of these rocks is the asteroid belts, and its origin story is, well, it's just incredible. Picture this, in the early chaotic days of our solar system, Jupiter's gravity was so ridiculously powerful that it basically tore a baby planet to pieces before it even had a chance to form. What we call the asteroid belt, that's the debris field. It's literally the cosmic rubble of a failed planet. And the sheer scale of this rubble field it's just mind-boggling. You've got Ceres, which is so big at 940 kilometers across that we actually call it a dwarf planet. Then you've got about 15 others that are bigger than 250 kilometers. But check out this last number. There are over 100,000 asteroids bigger than a single kilometer. That's a huge, vast field of cosmic debris just floating out there. You know, you can almost think of our solar system as a kind of museum, and every single asteroid is a fossil from a broken past. It's really cool. Scientists have even found what they call families. These are groups of asteroids that are clearly just fragments from the same ancient collision. Each one tells a story of some violent cosmic smash-up from billions of years ago. And they're not all the same, not by a long shot. The most common are the C-types. They're rich in carbon, very dark, and really primitive. Then, a little closer in the inner belt, you find the S-types, which are more stony. And then, you get the super rare M-types. These are the metallic ones, and we think they could contain just mountains of pure iron. This incredible variety is a huge reason why studying them is so important. Yes, studying these things gives us a kind of X-ray vision into our solar system's past. I mean, we've actually brought back samples from the asteroid Itokawa, we've figured out that Vesta had a volcanic history, and get this, we've even discovered that some asteroids have their own tiny moons, like Dactyl orbiting Ida. All these missions are what allowed us to measure their mass and density for the very first time. Okay, but this is where the story takes a much darker turn. Because not all of these ancient rocks stay put in the asteroid belts. Some of them get knocked out of their orbits and start heading our way. We have a name for these, near-Earth objects, or NEOs for short. And these can be asteroids or even the rocky cores of dead comets. The thing is, their orbits aren't stable. They're on a cosmic clock. Within about 100 million years or so, they're either going to crash into a planet or get flung out of the solar system completely. And look, this is not just some theoretical what-if scenario. This has happened, even in our recent history. Back in 1908, you had the Tunguska event, which just flattened an enormous forest in Siberia. And way more recently, in 2013, a meteor exploded over the Russian city of Chelyabinsk, and hundreds of people were injured. The explosive force from that Tunguska object, we estimate it was around 5 megatons. Now, this was probably an object only a few dozen meters across, yet it packed the punch of a major nuclear weapon. Think about that. And then there's the Chelyabinsk meteor. That one was even smaller, only about 20 meters wide, but it still released 500 kilotons of energy. That's many times more powerful than the bomb dropped on Hiroshima. It just goes to show you the incredible, terrifying power packed into even these relatively small space rocks. So here's the bottom line. If a tiny 20-meter rock can shatter windows and injure hundreds of people, what would a 1-kilometer asteroid do? The answer is pretty simple, and it's chilling. It would trigger a civilization-level catastrophe. Which naturally brings us to our final and maybe most important section, the race to save Earth. Because faced with this cosmic game of chance, we've started to fight back with the science of planetary defense. And here's some really good news. NASA's Space Guard survey has already identified and is tracking about 90% of the really big NEOs, the ones larger than a kilometer, the potential civilization killers. And the best news of all, none of them are a threat for the foreseeable future. But that still leaves 10% of them out there, completely undiscovered. So what do we actually do if we find one with our name on it? Well, there are two main strategies on the table. The first is what's called a kinetic impactor, which is a fancy way of saying we'd hit the asteroid with a super high-speed spacecraft to literally push it off course. The other idea is a nuclear standoff explosion. You don't hit the asteroid, you detonate a nuclear device near it. The blast would be enough to nudge it onto a new, much safer path. Now, the rules for this whole game are incredibly simple, but also incredibly difficult to pull off. Rule number 1, detect. You have to find any potential threat, and you need to find it years, or even better, decades in advance. And rule number 2, deflect. You have to intercept that object and push it with absolutely zero margin for error.
Because when you really stop and think about it, the most dangerous asteroid out there isn't one of the thousands we're already tracking. No, the biggest threat of all is the one we haven't seen yet. That's why constantly scanning the sky, that surveillance, is our single most important weapon in all of this.
So, asteroids tell us the story of our solar system's birth, but planetary defense, well, that's going to determine its future. It is a high-stakes race against time, and this race will end one of two ways, either with us winning or the asteroids losing. And that's a chilling thought to end on.